This is a small video tutorial on design and analysis of algorithm. These are my course objective. The main goal of this subject is designing a fast algorithm. There are some prerequisites for studying this course, which is a basic programming knowledge, knowledge on data structure, and knowledge on numerical methods. The topic I am going to take now is Introduction to Algorithm Analysis. First, algorithm is a well-defined computational procedure that takes some value or set of values as an input and produces some value or set of value as an output. A program is an expression of an algorithm in a programming language. So, algorithm lays the basic foundation for any program. What is the importance of analyzing the algorithm? First, to recognize the limitations of algorithms for solving a problem, then understand the relationship between your problem size and running time, analyze an algorithm's running time without coding, to learn techniques for writing more efficient code, and to recognize the bottlenecks in the algorithm. How we are going to study your algorithm? These are the steps: how to devise an algorithm, how to express an algorithm, how to validate your algorithm, how to analyze your algorithm, and how to test a program. If you have answer for these questions, we can study any algorithm's characteristic. Then now we are going to do approach your algorithm in an analytical manner, build a mathematical model of computer, study the properties of an algorithm, then prove facts about the time taken by an algorithm. Examine the methods of analyzing the algorithm, that is finding the correctness and efficiency. Decide whether you can able to solve the problem in real time. Then investigate the memory usage. What should be considered more important than the performance? Modularity, correctness, maintainability, functionality, robustness, user friendliness, programmer time, simplicity, extensibility, and reliability. For an example, let us consider of finding the least common multiple for the given two numbers. There are two methods, method 1 and method 2. We are going to analyze which method will best suits our problem statement. Method 1 is finding the multiples of both the numbers, listing down them, and finding the least multiple that both numbers have in common. We have taken the number 10 and 12. I have listed down the multiples of 10 and 12, and I have found that 60 is a common multiple that exists between them. Let us consider another example of finding an LCM of 48 and 80. I have listed down the multiples of 48 and 80. I have found that their common multiple is 240, which is the LCM of 48 and 80. Method 1 is a good method if your numbers are really small. If you have a large number, it might take too long to keep listing the multiples until you find a common multiple. To avoid this, we are going for method 2. First step in this method is writing the prime factorization, then selecting the common factors once, then multiply the remaining factors. This is the method 2 for finding the LCM of 48 and 80. 240 is the LCM of 48 and 80 using second method. Actually, both the method 1 and 2 is good, but method 1 is good if you are smaller number and method 2 is good if you are larger number. In the same manner, we are going to analyze various algorithm and we are going to identify which algorithm will best suits our problem statement. Thank you.